I want to work through a suspension bridge problem, which would be similar to problem 13 in our book in section 4.4. And I did start putting together a little bit of a sketch here, and I think our problem would probably be best based on the general function of a quadratic in this form, where we have the vertex of the graph being hk. And the reason for that is because I think we could easily determine the vertex of this particular situation. It's going to be 0, 0. Let's read the problem and you'll see why I started to sketch what I did. It says a suspension bridge with weight uniformly distributed along its length has twin towers that extend 85 meters above the road. In other words, this height here is 85. In fact, we could come up with the coordinates of a point like this because we know its y-coordinate is going to be 85. And we're going to see the fact that it says that the towers are 1,600 meters apart means that this will be 800 meters out to here. And therefore, the x-coordinate of this point is 800. And so we have the point 885. Now this would be the point negative 885. It's going to turn out that we're going to mainly just need 1 point. So we'll go ahead and just not bother to go ahead and label. Actually, I guess I could label it here. I don't know if it's going to be all that necessary to solve the problem. And in fact, this is negative 800 for an x-coordinate right here. Okay, now we know then the way we design the coordinates here, and this dotted line just represents x and y coordinates, x and y axes. This is just going to be the point 0, 0. Our vertex is going to be the point right here, is going to be 0, 0. Okay, now, it says here, the cables touch the road surface at the center of the bridge. That's how we knew that was going to be 0, 0 right there. Find the height of the cables at a point 400 meters from the center. Now, don't forget, this is not linear. So we can't assume that at 400 meters, exactly halfway across this side of the bridge, we'd be up at half the height of the tower. That is not true. This is not a constant rate of change here. So we're going to have to go ahead and see what else we could do to calculate what is the height here at 400 feet from the center of the bridge. In other words, we don't really know this y-coordinate yet. We don't know this height. Well, we're going to need a function to be able to plug 400 in to get that answer. So here's what we can do. Well, one of the reasons I picked this format of a quadratic function is because we already know h and k to be 0, 0. So that immediately brings us to this. If h is 0, then I just get ax squared here. And then plus 0 really brings me down to f of x is equal to ax squared. Well, f of x is really y. It's the output to the function. So we already know one of the coordinates that produced an output, right? It was when x was 800, we got 85. So what we can do is say that when x is 800, we got an output of 85, and we could solve for that a value. Okay? And when we go ahead and solve that, we're going to go ahead and divide both sides by 800 squared. And we're going to get that a is equal to 85 over 800 squared. And now we could write our function. Our function is going to be this, the complete function. It's going to be f of x. I just drew an arrow over here just to say this is what our function will result in. It's going to be f of x is equal to a, which in our case is 85, over 800 squared x squared, right? Ax squared. And then we don't have any k. Remember, our y coordinate of the vertex was 0. and our x-coordinate h of the vertex was 0. That's our function right there. So to answer the question of what would be the height, the output of the function at 400 feet over, that's where x is 400. And we're just going to evaluate this function at 400. And we will have 85 over 800 squared times 400 squared. And we just work that out in our calculator. Now, by the way, be careful. You cannot, you want to be careful about canceling when something's being squared. Okay? All right, so we're going to go ahead and work this out. So I have, and I might use my fraction feature here. So I got alpha y equals, give me that, and I got 85. Denominator is going to be 800 squared. I'm going to right arrow so that I get away from that, and I'm going to go times 400 squared, and I get an answer of the height at which we would go ahead and be 400 feet over on the bridge. The height at that point would be 21.25 feet. And so what we're saying here, or I'm sorry, I've been saying feet. I just read the problem here real quickly. Again, it's meters. And I might have been talking about feet throughout the problem, I'm not sure, but it actually was in meters. I just happened to notice it here when I went to put in my answer. Everything, all the math is right, but I may have been talking about the wrong unit here. It turns out that the height of the cables at 400 feet over is 21.25 meters.